Welcome to College Bio. Today we're going to talk about balancing equations. I'm going to go through the homework with you first, so if you already know what you're doing, you can start on that. If you don't know what you're doing, we'll go through the notes on how to do it after we talk about the homework. So let's click on that to open the homework up and take a look. First of all, you are going to do a blank Google Doc, or you can do it on your own paper. I recommend doing it on your paper and then taking pictures and inserting the pictures into a Google Doc to submit. That way all the pictures are in one place on that one document and you're only submitting one thing. But it's just easier to do any kind of balancing equations, math, anything on paper than it is on a digital Google Doc. That's how my brain works. That's how I function. If you can do it and be fine and not get confused and make it clean and easy to read, you are more than welcome to do it digitally. It's going to be easier though if you do a blank Google Doc because your assignment is, as you can see down here, a PDF. So you will need to copy the formula here into your Google Doc. So you'll type the title, balancing equations, and then in the body of it, you'll put number 1, iron plus H2SO4 yields. You'll type all of that out. You don't have to put the lines on it. I like the lines because it reminds you of where to put your coefficients to manipulate it. You'll see that you have two PDFs included here, 10 equations each. This is going to all be turned in as one Google Doc, okay? You're not going to turn in two separate Google Docs, just put it all on one Google Doc for me with 20 problems. You have to show your work when you're doing this. It is very easy for you to go into Google and just type the equation in and let it give you the answer. I know this. I've seen it done. It's not acceptable. Half of your points are for getting a balanced equation. The other half are for showing me how you did it. So you will need to make sure that you show me how you got your answer. There's two ways you can do this. If you're doing it on paper, you can do it with the counting method that we're going to go over in the notes. So you're going to list out all of the elements on each side and tell me how many of each one you have. And then as you add coefficients, you're going to add a second row or second column of atom totals on each one. Okay. You can also do it this way if you do it digitally. You just need to make sure that you keep the left and right very clearly separate. So type the equation and then hit enter. Underneath the equation, you'll do left, tab over, type right, and then list everything out underneath. So there's a huge gap here that you can see. Make sure you have a big gap like that. So it's very, very clear the two sides. The other way you can do it is you can show me your work as a description. So you can actually tell me in words what you did. The right side has this many atoms of each one. The left side has this many atoms of each one. I changed the equation by adding this coefficient here, and that made that atom count this, and then just keep going through. Okay. There's a quick note on cheating here because I had a few students a couple years back that were just copying answers from each other or from Google. They weren't doing the work or they were copying answers from each other. And so they were successful on the homework assignment, but they never learned the process. So when it came time to answering them on a quiz, for example, they were not able to do it. So all it does is cheat yourself. The whole point here is that you learn the process. Okay? So again, there's two PDFs, but you will do them as one Google Doc to turn it in. And again, if you do it on paper, take pictures, insert the pictures into the Google Doc. And that's what you should be turning in. Okay, If you've got this, you can go ahead and get started. If you need a refresher, we are about to go through the notes for balancing equations. So, why do we need to do this? Well, the law of conservation of matter says that atoms are not created or destroyed when we run a chemical reaction. That means whatever we start with on the reactant side, we will also have on the product side. If you start with 2H, you end with 2H. If you start with 4O, you end with 4O. The H and the O don't have to equal each other, but the H has to be the same on both sides, and the O has to be the same on both sides. So how do we do it? We're going to balance the equation. So the first thing we're going to do is count the number of atoms on each side. Then we're going to determine where they are not balanced, and we're going to add coefficients in front of those chemical formulas that contain those elements in order to try and fix it. We're going to keep doing that by adding and changing coefficients until we get them all matching, all of the elements matching on both sides. So if you look at number 1 here, 1A says you can have multiple instances of an element on the same side, and if we do, we're going to add those together. 1B is an example. It's not a realistic example, but it's an example. Oxygen exists out in the real world as mostly O2 with some O3 ozone in there as well. It doesn't really exist as a single oxygen. It just doesn't. So for our example, though, we have a water H2O plus an oxygen O on the same side. If we're counting atoms, the subscript counts the number of atoms of that particular element that are bonded together. So in H2O, we have 2 hydrogens bonded together. So that means we have 2 atoms of hydrogen, H2, 2 atoms. For the oxygen, there is no subscript. If there's no subscript, that's the same as having a 1 there. If you need to, put a 1 there on yours just as a placeholder until you get used to it. The proper method is to leave the 1 off and just know it's a 1. There's 2 oxygens on the same side, so we're going to add those together. They're each single oxygens, which means we have 2 oxygen atoms total. If it was H2O plus O2, we would have a single oxygen plus 2 oxygens, so we would have 3 atoms of oxygen. You'll see how this works in some of the homework assignment and some of the examples. So the next step, step number 2, is to add coefficients to try and fix this. When you add a coefficient, you're going to multiply it by everything in that molecule. When you multiply it by everything in the molecule, you're actually going to multiply it by that subscript. So for 2B, our example of O2, that's 2 atoms of oxygen. If we put the coefficient 2 in front of it, though, we now have 2 molecules of O2. So 2 times 2, we have 4 atoms of oxygen. You're going to keep changing those coefficients until you have equal amounts of each element on each side. One more thing to remember, you cannot add or change the subscripts. So that little number that comes after the letter stays the same always. So O2 is always going to be O2. You're never going to change it to O4. Okay? You can make it 2O2 or 3O2 to change the number of molecules, but you cannot change that subscript. We're going to take a look at the example that has magnesium and oxygen in it. When you write these down, I have it written down 4 times so you can see the progression of each step. You're only going to write it down once, and you're going to do each of these steps on that same problem. Just cross out the old and write the new. So we're going to start off by writing the equation, and then underneath the equation, we're going to list out each element for each side. Once we've got that done, we're going to come down here to number 2. And we're going to count the atoms on each side. We've got no subscript here, so there's one magnesium. This is O2, so that's two oxygens. Over here, we have one magnesium and one oxygen. So we're going to count those atoms. So this is what it should look like. So I've placed our numbers in red here. So you can see one magnesium on each side, it's equal. And then oxygen is uneven. You have two on the left and one on the right. So we need to fix oxygen. So we're going to do that by placing coefficients. We have the O2 on the left here. This O is a single O. Anytime you have something odd, that's probably going to be where you're going to start, especially if it's bonded with something else into a molecule. So right now, O is the only thing that's out of whack. So that's where we're going to start. And we're going to add a 2 in front of this whole molecule, because remember this 2 gets distributed throughout. So 2 times 1 magnesium is 2 magnesiums. 2 times 1 oxygen is 2 oxygens. So now we've made our oxygen equal, but look what we did to our magnesium. Magnesium's out of balance now. So you'll see that I just crossed off the old number that has changed. So the original ones that we got over here, I've crossed them off and replaced them with the 2's. So in order to fix magnesium, we now have to make this magnesium a 2, and we do that by placing a 2 in front. So again, we cross off old numbers, place it with the new numbers. And that's it. We've got a balanced equation. That's all there is to it. So let's try another example. This one is a little bit more difficult, but it's still fairly easily done. I'm actually going to go about this a different way than I normally would to show you that you can keep manipulating coefficients as much as you need to. First thing we're going to do is count our atoms. Cu2 means we have 2 coppers. O with no coefficient, that's 1 oxygen. Same thing with carbon. And then on the right, we have 1 copper, 2 oxygens, 1 carbon. And remember that I told you if we have something that's odd and attached to something else in a molecule, that's where we should start. That's just going to make our lives easier, because on this one, we're out of balance at copper and oxygen. Copper is even here. It's odd over here, but it's by itself. Oxygen is odd here in the molecule and even over here in this molecule. So I would probably, if it were me, start with the oxygen to balance it out, because anything we do to fix this oxygen right here is also going to change the copper. So if we fix copper first, then we come back and fix oxygen, our copper is going to be out of whack again. And you'll see that because we're actually going to start with copper on this one, so I can show you how that works. So copper, you have 2 on the left, 1 on the right. So think for a minute about what you would do to fix that. All right, hopefully you came up with, you need to change this copper on the right to a 2. By doing that, you cross off the old 1, and now you have 2 coppers, so our copper is equal. Carbon is still good to go. We haven't messed with that. So this green 2 that we put up here in front of copper changed our copper atoms to 2. So now we need to fix oxygen. It's the only thing left that's out of balance. So we have 2 oxygen on the right. We have 1 on the left. The only way to fix that 1 and make it a 2 is to put a 2 in front of it. So now we've got this red 2 in front of Cu2O. 2 times Cu2 is 4. 2 times O1 is 2. So now our oxygen is fixed, but our copper has changed again. So now we have to come back over here to the right because it's the low side. You have 4 on the left, 2 on the right, so the right is the low side, and we have to fix this copper again. We can't just throw another 2 in front of it because that's not how it works. So we need to get rid of the 2 that's there and come up with something that will equal the left, which is 4. So if we change that 2 to a 4, we now have 4 copper on the right, 4 copper on the left. Oxygen is equal, carbon is equal, and now we're balanced. So that one was a little bit more complicated because of where we started, but I wanted to do it that way to show you that you can continue to change numbers if you need to. Okay, so here's an example for you to try, so go ahead and pause the video, give this one a shot, and then restart the video and I will go through it with you. Okay, great. Welcome back. Let's see how you did. Step number 1, we're going to count the atoms. So you should have 2 hydrogen and 2 oxygen on the left. And then on the right, you have 2 hydrogen, but you have 3 oxygen because this O is a single and this is a double. So 2 hydrogen, 1 plus 2 is 3 oxygens. So in order to fix this, we're going to need to go fix our oxygen because our hydrogen's already good. So we need to think of how to fix our oxygen. Well, we have 3 on the right, so normally we would think let's go to the left because there's fewer of those. We have to, though, go to the one on the right that is an odd oxygen and make that an even number. The only way to do that is to put a coefficient in front of it because remember we cannot change the subscript. So now this 2 is here and it goes with both parts of this molecule. So 2 H2s means we have 4 hydrogens, 2 O1s meaning we have 2 oxygens there. However, don't forget to add this other oxygen on, so we actually have 4 oxygens. Now that we've done that, there's more on the right, so we have to fix the left. So we need to put something in front of the H2O2 to fix it, and that happens to be a 2. So now we're balanced. We've done a lot of these with 2's in front of them. You can put any number up there. Some of the ones in your homework have numbers like 7, 9, 14, 13 in front of them. So there are some crazy ones on there. It is not always going to be a 2. Hopefully you guys are good. There are 2 more problems on here for you to try yourself. A calcium one and a nitrogen one. The last slide actually gives you the answers for both of those sample problems that you're going to try on your own. Please don't look at it until you've made an attempt. You're just going to look at the answers to see if you were correct or not and try and figure out where you went wrong. Go ahead and get started on your homework. It is due on Friday of next week because we're doing this on block day. So you've got some time. Make sure that you are working on it here in class so you can work with your classmates. Remember that everybody has to turn it in, but you can work together on this type of assignment as long as you understand the process and turn in your own work. You've got your classmates here to ask about it and get help from. You've got me to talk about it with and get help from. So get as much of this knocked out in class as you can. When you're done, the rest of the time is yours to finish your prior lessons that you may not have finished yet. Good luck. I will see you next time.